tears of my calculus students. I think this is the best thing anyone ever could have given me, a coffee cup that says, tears of my calculus students. And given the amount of whining that you all do, we're going to have this filled very quickly. Very, very quickly. Maybe he should have gotten me like a keg or a gallon container. I'm excited. All right, so here we go. We're going to do a quick little exploration. I want to see how good of a listener you all are. You need a pencil. We're on page 11. Okay. You're going to need a pencil. I don't want you to do this first part in pen, so you need a pencil. And you need a ruler. Name, are we filming back here? Yes. Okay. And you need your listening skills. Okay. So here we go. Here we go. Yep. And remember, these are rulers. They are not ninja blades or propellers or drumsticks. Whatever it is you were just doing over there, son, they're none of those things. No, 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 not ninja blades. Not ninja blades. Okay. I need you to draw a function. I'm really testing your math vocabulary. Stop slapping my favorite student. Okay, draw a function. Okay. Don't draw my function, draw a function. It doesn't matter which one it is. Draw a function. I see Jackie's got a parabola, somebody else has something exponential, somebody else has something that kind of wiggles. These are all functions. Now, for your function, select a closed interval. A closed interval. So pick a starting point, pick an ending point. I don't care where they are. It's your choice. We're going to label those as x equals a and x equals b. I want you to find the endpoints for that interval. Here they are. Boop, boop, boop. Here they are. Boop, boop, boop. And I would like you to use your ruler. Please be as careful with this as you can. Use your ruler to connect those endpoints with a special kind of line. You guys know the word for this kind of line. It's a secant line. We're going to use a secant line because we're connecting 2 points. Everybody okay? You've got a function, you have a interval, you are connecting the endpoints with a secant line. Your graph doesn't need to look like mine. And I'm curious, how many of you can find a place where the tangent line is parallel to the secant line? I just packed a whole lot of math vocabulary in there. The question is, how many of you can find a place where the tangent line is parallel to the secant line? Oh, Pedro's got a great example. I can't wait to look at yours. Okay, Carlos, did you find a place where your tangent line is, well, for your graph, not my graph. A place where your tangent line is parallel to the secant line. How many of you guys are able to find a place where this happens? Jose's got a place. I would expect a whole lot more than this. Okay, you can see it on my graph, Carlos, where?
Where x equals a.
Where x equals a?
X equals b.
X equals b?
On the side.
I'm looking for a place where the tangent line touches one time, is parallel to the secant line. Does anybody see a place on my graph where that happens? Like the maximum, like right here? That would have a slope of 0. That doesn't seem to be the slope of my secant line. How about if I imagine just like sliding this up? Would you guys agree, like right about there? Okay, look at your graphs again. How many of you have a place on your graph where the tangent line is parallel to the secant line? Jackie's got a place. Delia seems to have a place. Abraham seems to have a place. Carlos has got a place. Okay. I don't know why I almost called you Rodolfo. You're not Rodolfo. Roberto seems to have a place. Eric has a place. Naum has a place. Just about every... I don't even know where Rodolfo came from. Okay. Just about every single graph that is out there, just about every single function that was drawn, every interval that was selected, just about everybody found a place where the tangent line is parallel to the secant line. Are we okay? Okay. I want to plant a little seed and get you guys thinking. So last class, it happened with everybody's graph. Every graph that was drawn, every interval that was selected, we made a secant line, we made a tangent line, they were parallel. Pedro, can I see your example? Okay, can you open that up? Thanks, sir. Look at Pedro's example. I could not have asked for a better example. I hope this comes out on the camera. So Pedro drew a function. Does this count?
Yeah.
Does this count as a function?
Yeah.
Absolutely. He selected his endpoints of the interval. He made a secant line connecting the two endpoints. Everybody good? My question is there a place where the tangent line is parallel to the secant line?
Yeah.
Where? Kaylin, where do you see it? At the cusp point? Okay, Bento doesn't seem to like this. A couple other people don't like this. Here's your secant line. Here's the tangent line. Do they have the same slope? Okay? So I hear you saying, no, it should be flat, like it's horizontal. There is a much bigger problem with Pedro's graph. There is a big reason why you shouldn't fall for the trap and say that the secant line and the tangent line have the same slope.
Oh, is it
Because?
Is it because it's not differentiable?
Oh my God, say that one more time on camera so the kids know how I hear you.
It's not differentiable.
Yeah, I'm sorry, what? Yeah?
I mean, the function.
The
is not,
function is not differentiable here. Why?
because it's a cusp point.
It's a cusp point. What's the slope of the tangent line here? Not zero. You cannot talk about slope of a tangent line here at a cusp point. So for Pedro's example, Pedro is like sitting up tall. He's like, I did it, I'm gonna go tell mom. Okay, the secant line and the tangent line don't have the same slope. Nice job. Maybe you accidentally got there, but hey, nice job. Okay, do me a favor, get this in your notes. Get this in your notes and label this counter example. This is a function that does not work. This thing that we're going to talk about isn't going to be true all the time. There are going to be conditions that have to be met that we're going to talk about. Okay. So you've got your triangular shape, you've identified your endpoint, use that ruler, make a really nice secant line, right? In the de Rosier family, we all have OCD. If it's not a right angle, it's a wrong angle. Wow, no jokes today. Okay. Yeah, too bad. Okay. And this guy up here, your cusp point, what we know is that f prime, the derivative, does not exist. Most of you drew functions that were really nice. How many of you guys drew like nice, like curvy functions? Just about everybody. Everybody drew continuous functions as well. Continuous, smooth functions have this property that we're going to talk about, but these non-differentiable functions won't have the property. Okay, so with all that said, Pedro, well done, son. Okay, if you need a letter of recommendation for college, let me know. Okay, we'll talk about this moment. All right, so here it comes. This is the mean value theorem, and I can tell you of all the ones that we're going to study, mean value theorem is probably the one that you might understand the least. And I'm not saying that to set the bar low, but just to let you know, like, this is going to be the one where you're going to walk out of here and be like, I'm not 100% sure what happened today. Don't worry, we're going to come back and do it again tomorrow. We can put the rulers away, you don't need them anymore. So just put them back in the supply kit. And I'll read the mean value theorem to you, and then we're going to do an example and blow your minds. Okay. So mean value theorem for derivatives says this. Mean value theorem states that if a function is continuous, oh, that's an important adjective. Continuous on the closed interval. So what does that mean? Nope. Wrong adjective. It's a, what? The fact that it's a function already, but continuous means to us. You guys know, it's been a while. No what? No jumps, no breaks. What else? No vertical asymptotes, no poles, right? A nice continuous, I can put the ruler away. Okay, nice continuous, I can draw this on my paper without lifting the pencil off the paper. Continuous on this closed interval AB. And differentiable, I think this is what you guys were thinking of earlier. Differentiable, the derivative exists. Okay, the derivative exists. Some people call this smooth. There's no like sharp edges, there's no vertical tangent lines. If you have a function that is continuous, no holes, no jumps, no breaks, no vertical asymptotes, on a closed interval, and differentiable, so smooth, derivative exists everywhere, then you are always going to find a place, some value c, and I want to emphasize inside the interval, where this next statement is true. Let me write it and then we'll tear it apart. F of b minus f of a over b minus a. You're always going to find a value of c that makes this statement true. That f prime of c is equal to f of b minus f of a over b minus a. If your function is continuous on closed interval, differentiable on the open interval, you'll always find this value of c inside the interval where this guy's true. Okay, let's add a little bit over this. F of b minus f of a over b minus a, you guys know what that expression is.
Quotient.
Not quotient rule. It is a quotient because it's division. This is not tan, oh no. F of b minus f of a over b minus a, there's no limits here. This is slope. Slope of what? F of b minus f of a over b minus a, you guys are thinking big brain here.
Slope of
This is slope of, not tangent line,
secant.
secant line. Slope of secant line. Remember that line that you drew first? F prime of c, now we're in calculus class. This guy here is slope of tangent line. What the mean value theorem says is if you have a function that is continuous on the closed interval, differentiable on the open interval, this is always going to happen. There will always be at least one place where the slope of the tangent line equals the slope of the secant line. Kind of okay? Just kind of believe me on face value right now?
Yeah, that's
Okay, let's go over to the diagram. Okay. So here's my little sketch. Visually, would everybody agree that this is continuous?
Yeah.
No holes, no jumps, no breaks, no vertical asymptotes. Is it differentiable?
Yes.
It's smooth, right? I don't see any cusp points. I don't see any vertical tangent lines. So my function is continuous on this closed interval, and it's differentiable on the open interval. So what the mean value theorem says is, if I look from here at x equals a to over here at x equals b, and I connect those 2 points with a, what kind of line again? Secant line, that there is always going to be at least one place inside the interval where the tangent line and the secant line have the same slope. This is the MVT. I can see from the graph, imagine shifting your line up. You guys would probably all agree like somewhere around here. You've got a tangent line. What we care about is the x-coordinate. The x-coordinate where this happens is the c value, and the c value is inside of the interval that I picked. It'll always be true that a is less than c is less than b. This is your mean value there. Right now, you might be like, why, who cares? We're going to get to the who cares in a little bit. Okay? And I want to flag the fact that this is called an existence theorem. We've dealt with one other existence theorem so far this year. Anybody remembers it? It's been a long time.
What does it start with?
What does it start with? Oh, that game. It starts with an I.
Intermediate value.
The what?
Intermediate value.
Son, whatever you had for breakfast, we need some. The intermediate value theorem. You're like, what's the intermediate value theorem? Had nothing to do with f prime. Intermediate value theorem had to do with a continuous function. You have a point up here, you have a point down here. Finish the story. You have a point up here, you have a point down here.
They must equal to each other, right?
Not that they're going to be equal to each other, but for any y value in between, there has to be some place where the function's equal to that. We use it a lot with finding roots, right? You'd say like, oh, there's this point up here above the x-axis. There's some point down here below the x-axis. What has to be true? There's going to be a root if you have a continuous function, but we never knew where the root was. We just knew that the root had to exist. All right, so with that said, let's really roll up the sleeves. We're going to do some calculus. It's going to be beautiful. On page 12, for those of you that like and or need a checklist, here's your checklist. I'll give you a minute to kind of take this in. This is going to be, if I was one of those teachers who were like, what are the 6 steps for a mean value theorem problem? There they are. So give them a read, and we'll see what we can do. Next page, These problems are going to be long ones. Let's give it a whirl. For the function f of x equals 5x minus 4 divided by x on the interval -4, -1, find the value of c guaranteed by the mean value theorem, or tell me why we can't use the MVT. This is what a lot of these problems are going to look like, they're going to feel like. So the question is MVT. Can we use the MVT? What would have to be true to use the MVT? The function is continuous on the closed interval. And the second thing? Go check the notes. There's 2 conditions here. Continuous and derivative exists, differentiable. So let's start with continuity. Okay. The function is f of x equals 5x minus 4 over x. Is that function continuous? And you might look at it first and say, I have no idea. Right? This is not a function that you recognize. It's not a parent function. If you had access to your calculator, you could probably determine continuity or not. But the question about continuity is actually a pretty basic one. Is there anything wrong with this function? Does this problem have any problem areas or problem values? Yes, it does. There's a problem with this function. There is a value that you guys know that if you try to evaluate the function at that point, you'd have a problem. 0. Carlos, what would be the problem?
Can't divide number by 0.
I can't divide by 0, right? And since I can't divide by 0, what's the value of the function at 0? Doesn't exist. So I could say f of x is not defined at x equals 0, which means f is not continuous at x equals 0. So last class, right away, they're like, great, the function's not continuous. We're done.
Remember asking about the interval.
One more time?
You're asking about the interval.
Tell me more about this.
It doesn't care what's on the outside. It cares what's on the inside.
Oh, that's very deep. It's not about what's on the outside, it's about what's on the inside. I've gotten my way through life this way. The function has to be continuous on the interval -4, -1. We know we have a problem at x equals 0, but is the function continuous on this interval?
Yes.
We're okay with this?
Yes.
There is a problem with continuity, but not where I care about. Okay, and so I'd say something like, however, f is continuous on the interval -4, -1, check, continuity established. Differentiability, I'm going to give you a little bit more of a nudge. Differentiability is just asking the question, does your derivative exist? Well, let's go find the derivative and see what happens. And since you guys just finished this unit, I would think this would be a pretty straightforward question. Right, I want to check differentiability, I want to check the derivative. How are we going to find the derivative? Quotient rule. Okay, take a minute, show me that you know what's going on with the quotient rule. Okay, low, d high, minus high, d low, low, low. I hope everybody's feeling really good with quotient rule. We've got that. I'm going to simplify this a little bit, and you'll see why in a little bit. So 5x minus 5x minus 4 times 1 is the same thing as negative 5x plus 4. There's my derivative, f prime. Does the derivative exist everywhere? Or does the derivative have some problems? The derivative equals 4 over x squared. What do you think, Jose?
There's a problem at 0.
There's a problem at x equals 0. What's the problem at x equals 0? What can't you do at 0? You can't divide by 0. So the derivative could not exist at 0?
No.
Okay, so I'd make a note like f prime does not exist at x equals 0. Does it have any other problems? No. But it does exist everywhere else. Guess what? The derivative has a problem at x equals 0. The derivative doesn't exist. But does the derivative exist in the interval that I care about? Does it exist from -4 to -1? 0 is the problem area. Does 0 fall in the symbol?
No.
No. Okay, so I'd say something like, so f is differentiable on -4, -1. You can either say, Jose, f is differentiable, or you can say f prime exists. Same thing. Okay, I know you guys are like, God, we gotta be done now. We've checked continuity. We've checked differentiability. Guess what? All this means is the MVT applies. That's all we know right now. It is legal for you to move forward with the MVT. Now you've got to go figure out the value of C. And here's what we're looking for. We're looking for the C that satisfies this relationship. That f prime of C equals f of B minus f of A over B minus A. What I did last class, and it worked pretty well, let's go find f of B minus f of A over B minus A. That is f of -1 minus f of -4 divided by -1 minus -4. The A and the B are the endpoints on your intervals. F of -1, you're going to plug it in. F of -4, we're going to plug it in. We're just finding slopes. Take a minute, go through, do that, see what you can do. What is that? 5 times -1 is -5. Minus 4 is -9, divided by -1 is 9. F of -4, 5 times -4 is -20. Minus 4 is -24, divided by -4 is 6. -1 minus -4, same as -1 plus 4, that's going to be 3. We get 3 over 3, it's going to be 1. Can anybody else verify that that's right? Okay. The 1 isn't the answer. This is the slope of the secant. It's your goal. You're looking for the just right value of C that makes the derivative equal 1. I'm in. What we need is for the derivative to be equal to 1. Right? This guy over here is your derivative. Thanks. Okay, have a seat. We'll talk about it. Okay, 4 divided by x squared is equal to 1. What's x? 4 divided by x squared is equal to 1. Some of you are able to reason this through in your head. Okay. Okay, 2 is part of the solution. If you're not sure, maybe you want to multiply both sides by x squared, and you get 4 equals x squared. Maybe here it's a little more obvious what the answers are. This should be 2 and negative 2. 2 and negative 2 would be your answers to that question. Now, before we move on, how many solutions do we have? Let me ask this question again. How many solutions do we have that are inside the interval that I care about? Which one? Negative 2, right? You have to pay attention. The mean value theorem says there's a place inside that interval, not outside, inside the interval. So this guy here is the value of C that we're looking for. X equals 2 is the one we're going to throw out. Fancy word for this, Jesus, is extraneous. It's an extraneous solution. I know you've heard that in Algebra 2 and Pre-Calc. X equals negative 2 is the one that we care about. These are clearly going to be some long problems, some of the longest ones we've seen so far. Okay? All right, see what you can do with the next one. We'll talk a little bit. Yep, I did. It's right there. Where's there? Ah, okay, over there with the apparently he cried a lot.
I'm already crying. I haven't even started the unit.
The smarticle particles are working today. Most of you have already figured this out. Okay, quick reminder, what are the 2 conditions that we need? Be specific, continuous where? On the closed interval. I want to think about brackets. Last period I asked them to show me bear clause. I meant this, they did this. Paul did this, it was very weird. Okay, when I say bear clause, I'm like closed interval. Show me your bear clause. Okay, the function is continuous on the closed interval, not this. This was very weird. And it's differentiable or smooth on the open interval. Show me your parentheses. Okay, I'm not sure what you're doing there, Beto. You're like, nice. No, son. Continuous on the closed interval, differentiable on the open interval. Which property fails here? What do we know about F? It's continuous? This function is continuous?
No.
Where? Roberto, why not?
-1.
F does not exist at -1 because we would then be dividing by 0.
Yes.
So guess what? I'd want to say something like F is not continuous. Give me the interval. Okay. Because F doesn't exist at -1, the function's not continuous on -2, -2, positive 2. So guess what? The MVT does not apply. Meaning, don't check for differentiability. That's a waste of your time. Don't find the slope of the tangent line or the secant line. It's a waste of your time. The mean value theorem cannot be applied because your function's not continuous. I think everybody's good? All right, keep going. See what you can do. Trust your smarticle particles here.
Because it's so much closer. It wasn't at 0 minutes.
So like this one.
Right, but the difference is this function is not defined at 0, but 0 isn't in the interval that I care about. I don't need the function to be continuous everywhere, just on the interval I care about. Okay. So basically you have the rest of this period. And time, smart guy, you worked hard, you do this.
That's why you say recording.
You guys are doing a great job. You're checking for continuity first. If the function's not continuous, don't do anything else.
I have a question.
Hit me.
So like after you plug in like that one and you keep plugging it in.
So, okay, you could try that, and that is going to take an awfully long time. How many numbers are there between -1 and 1? Don't say 3. God, don't say 3.
A bunch of numbers.
A bunch of numbers, because of the decimals in the front. There's an infinite number of numbers. You've tried 1. You have an infinite more to go.
So
There has to be something else here. Okay, if I could stop all the conversations, everyone is so hungry to be like, oh my god, I want to talk about continuity. What kind of function is that? Go back to Algebra 2. Go back to pre-calc. F of x is more important than the word cubic. It is begins with a P. My God, no. Kids in Ohio are like, those kids are so dumb. They just said parabola. No. Begins with a P. How about polynomial? But the fact that 2/3 of you said parabola makes me want to throw up. Okay, this is a cubic polynomial. What do we know about any polynomial on the planet? Any polynomial you've ever seen? They're all continuous. All polynomials are continuous. F is a polynomial, which means continuous, because right, the issue with continuity is, are we dividing by 0? Are we taking square roots of negative numbers? F is continuous everywhere. Are we good?
Yep.
So continuous everywhere. So do we have continuity on our interval?
Yes.
Therefore, continuous on the interval -1, 1. Good. Next thing to check. We've established continuity. Next thing. Differentiable. Differentiable. Does that derivative exist everywhere? Go find that derivative. What is that? 3x squared minus 2x minus 2. Does that exist? Has to exist, right? I'm not dividing by 0, no square roots, no nothing. So f prime exists everywhere, which means f is differentiable on, be careful here, parentheses, -1 to 1. So the MVT applies. Okay? And although the fact that the MVT applies makes me happy, I'm very happy about this, it means that there's more work to do. We have continuity, we have differentiability. Next, we're looking for this relationship. I need f prime of c equal to f of b minus f of a over b minus a. I like to find the slope first. So I want to make sure I don't blow it on the endpoints here. The interval is a to b, -1 to 1. So f of 1 minus f of -1 divided by 1 minus -1. F of 1, you've got to plug it in. F of negative 1, you have to plug in. F of 1, if you need to go on the side, 1 cubed minus 1 squared minus 2 times 1. 1 minus 1 minus 2. Negative 2. That's for F of 1. F of negative 1 is negative 1 cubed minus negative 1 squared minus 2 times negative 1. Negative 1 minus 1, is that plus 2? 0. 1 minus minus 1 is 2. If I simplify that, I'm going to get negative 2 over 2, which is negative 1. Is everybody okay with negative 1?
Yes.
Okay. Negative 1 isn't the answer. It's the goal. Right? It's the goal. This is slope of secant line. What I need to know is, where will your tangent line have this slope? So we need to do a little bit more work. Okay, find that derivative. You guys know that's 3x squared minus 2x minus 2. Set it equal to negative 1, and go solve that equation. It's an algebra 2 question. 3x squared minus 2x minus 2, where is it equal to negative 1? Any one of the 14 Algebra 2 teachers you had that year would tell you to do the same thing here. 3x squared minus 2x minus 2 is equal to negative 1. You want to solve this by factoring. But if you're going to factor it, it better be equal to 0 first. So you want to add that 1 to the other side? So you're going to get 3x squared minus 2x minus 1 is equal to 0. You want to factor. You want to solve it. If you need to go and do the box method, go do the box method. However you factor this, it's going to be 3x and x, and I think this is minus 1, and that's plus 1. That should work. Solution, if 3x plus 1 is equal to 0, then that means that x is negative a third. If x minus 1 is equal to 0, x is going to be 1. So how many solutions? 2?
Yes.
Let me ask the question again with clarity. How many solutions inside the interval?
1.
How many inside the interval? There's just 1. Ashley, why is there only 1 here, not 2? No matter what she says, why is there only 1? Inside the interval. Here's the problem. 1 is not inside the interval, it's an endpoint. Okay? So we're not going to let x, we're not going to choose x equals 1 because it's an endpoint. It is possible that you're going to have more than 1. That can absolutely happen, but in this case there's only 1. Are all the friends okay? You guys are doing a great job. See what you can do the next one. Trust those smarticle particles. Carlos, almost didn't see you there in your camo. Actually, that's not true. All the folks in this room that I watch, you get watched a lot. Juan gets watched a lot too.
Juan's here?
Yeah, he's here. He's over there. He's taking a test. Don't interrupt him. He's getting the high score right now. Of all the students testing today, his will be the highest score.
Nobody else.
He's the
Way to go, buddy! My favorite color.
What did you want me to
Absolute value, I mean, it's because
I don't know how to do it.
Wouldn't be wrong because the absolute value is
So nothing wrong. We actually
Hole in 1, write it up. Hole in 1, write it up, write it up, write it up.
So then what?
Okay, so how do you understand that? I'm sure.
So,
I can't say it.
Yeah, like,
I can't.
Okay, so when she grades your test, as long as she grades it, we're good.
it is.
MVT value theorem, MVT.
See, you said it, I couldn't say it.
Okay, from walking around, I think just about every group has come to the same conclusion. MVT, no good here. No good here. But I think the key for everybody was knowing what the graph looks like. Absolute value of x minus 3 looks like that. Okay, so careful. Tell me about continuity. Is or not continuous?
It is.
It is continuous on the interval 0 to 6. However, f is not differentiable where? At x equals 3. At x equals 3. Because of the cusp point. Because of the cusp point, and so your conclusion? MVT does not apply. Seriously, you guys are like, we're in a good place with the mean value. Tomorrow's going to shake you up a little bit.
Why?
Because we're going to leave this recipe.
What do you mean?
We're going to leave the recipe. They're not going to look the same.
You can't cook without the recipe.
Hey, well, yes, you can. You just may not get people to eat it. All right, one last one. One last one. This one I want to lead the charge on because we've only got 4 minutes, and this one's an important one. And oh, looky, trig. Yes. For the function g of x equals x minus 2 sine of x on the open interval negative pi to, on the interval negative pi to pi, find the value of c guaranteed by the mean value theorem, or tell me that it does not apply. First question has to be, is the function continuous? The graph of g equals x minus 2 sine of x, is this continuous? Another way to ask this question, does it have any problem areas? Are we trying to divide by 0?
No.
Are we trying to take a square root of a negative number?
No.
Absolutely not. You could also argue that the graph of x is continuous. What about the graph of sine of x? Known to be continuous? So I would say something like g is a continuous function, is continuous function because y equals x and y equals 2 sine of x are continuous. Okay? Differentiable. Go find that derivative. G prime. G is x minus 2 sine of x. G prime is 1 minus 2 cosine of x. Does that exist?
Yeah. Yeah.
Right? Cosine of x, nice, smooth function, no problems. G prime exists everywhere, which means G is differentiable on the open interval negative pi to pi. I know I'm going fast because I really want to get to this next part. So, the MVT applies. You have to check continuity, you have to check differentiability. You've done that, hurrah! Now what?
Now you make sure that F prime C.
Careful, I heard F prime.
G prime of C equals.
I changed the function name on you because I do that all the time. So G of pi minus G of negative pi over pi minus negative pi. Don't throw up yet. G of pi just means go to your function, everywhere you see x plug in pi. So we've got pi, oh, the teeth! Pi minus 2 sine of pi minus G of negative pi is negative pi minus 2 sine of negative pi. divided by pi minus negative pi. Yes, I'm pushing, I know. G of pi, or G of b minus G of a over b minus a. Sine of pi. Pi radians, same as 180 degrees, but sine of pi is
0.
0. Sine of negative pi, still 0, because you just went unit circle in the other direction. So what do we have? Pi minus negative pi, 2 pi, divided by pi minus negative pi, 2 pi, that's equal to 1. That's the goal. And then your last,
That's slope of 10, right?
that's slope of tan, and then you need 1 minus 2 cosine of x to be equal to 1. You're going to finish it off. You'll get negative 2 cos x equals 0. You'll get cosine of x equals 0. Anybody know where cosine is equal to 0? I heard pi over 2. Is that in the interval? Yes. Anybody know any other place where cosine is equal to 0?
2 pi over 3.
3 pi over 2, I agree, but that's not in the interval. There's one more place.
Negative 7 pi over.
Negative pi over 2. Abraham, can you show us negative pi over 2? Start at 0. Negative pi over 2. You go down 90 degrees. And that's in the interval. So in this case, 2 solutions. Okay? Tonight's homework assignment number 52 is just mean value theorem stuff. I'm picking that up tomorrow as well as assignment 51. She's just so tall as it is. Whoop. I should probably